Well, hello everyone. We are in the middle of Hannover Messe 2025, and today we have a special guest here in our film studio in Laatzen, our Amazon site right across of the Messe fairgrounds. So yeah, I'm happy to have you here with us, Elvira.
Thank you, Martin. Thanks a lot. Hello, everyone.
Yeah. So let me perhaps tell a little bit the history how this
Yeah.
came together, right? So I think it started during the pandemic, where Elvira and I shared thoughts about a video of mine around how to tell difficult context in easy language and how to collaborate and build design review culture across domains and things like that. And I guess around that time you came up with the idea of, hey, this resonates a lot with what I'm doing, so let's do an interview about this.
Yes.
And then it took quite a while, right?
Yeah.
A lot
But
of
finally,
things.
we're here, so it was worth
Absolutely.
it.
So yeah, and now it fits. It seems to fit together from all perspectives, right? The Hannover Messe is happening across the street. They talk about things like energy efficiency, sustainability. We just met yesterday at our booth, having interesting discussions around the topic. So yeah, looking back at that, Elvira, perhaps if you could just tell a little bit about yourself, what is driving you in
Yeah.
life, and then we can take it away from there.
Yes, Martin, thank you so much. I've been in the compressed air and pneumatics for the past 13 years. And what I realized that energy impact and the CO2 impact is pneumatic and compressed air is responsible for 1.5% of the total CO2 emissions.
That's a bunch.
That's a bunch. And you know what is the craziest thing? That we can reduce it almost in a half if we're designing it correctly. So, we have these problems that systems are oversized, or maybe the application was not chosen correct. Components are not matching together, although there are many great solutions. But still, it's very hard to design correct systems that consume less energy, although there are some best engineering practice. What I think what is missing is methods for the designing of them, the system approach, but also the collaboration. So because
Yeah.
I think our industry is so fragmented. So we have a compressor room in one side, and then you have the distribution through the full factory. Then you have production lines, and then you have components, such Emerson components. And there are so many people are involved, and in the end, so many companies are involved but they're so fragmented. So they don't talk with each other. It's completely different domains and completely
Yeah.
different working
Yeah.
groups,
Yeah.
standards, and so on. So this holistic approach is missing not only on the tools perspective that I'm working with, right? Like I'm working on the system approach, but it's missing on the people approach, on this connecting. And what I find really fascinating about your method that I learned, that you bring both together. You bring people together and system, the technology together. And this is, I think, really a great point where we can push this idea of the correct systems design, because it's not a really rocket science. We know that. It's not so hard. And today I would like to learn more about your method and to show this amazing method to our listeners also and viewers.
Yeah, thanks. You mentioned good points, collaboration being perhaps the biggest part of it, how to communicate better. And you already took the ball of leading this interview, which is absolutely correct. We are just being the host for the location here in
Yes.
our film studio. But in fact, it will be you hosting this interview and
Yeah.
continuing asking me some questions.
Yes, thank you, Emerson Studio, for hosting me and
You're welcome.
being able to talk about these important topics.
Yeah. So it's up to you now,
Yeah, so
guiding us through.
I'll take the microphone, let's say, imaginary microphone. Martin, we know each other for some time, and I really love your approach and methods, and I learned a lot from you. I wanted to ask you why sustainability is so important for you. Tell us about yourself a little bit. So what are you doing, Emerson, and why the sustainability topic is so important?
Yeah, fair enough. Well, at Amazon, my current role is called Senior Innovation Champion,
Okay.
which sounds like very big words, but in fact, I'm still just helping our teams to collaborate better, understand each other better, understand better what the customers want, which brings me often to jump around in front of whiteboards,
Okay.
sketching, drawing,
Okay.
sometimes even playing some games with the teams
Okay.
to better think into the topic. And this basically connects to what I like doing in private as well, right? You know, I have some kids
Yes.
at home and we love playing games as well. We commute all the time using our bikes. Hanover is a very good ground to go by bike.
It is.
And this already leans into, yeah, if you have kids, you of course think about, yeah, we have to keep this planet intact
Yeah.
Somehow. So how can I contribute to this? And this has become a more and more critical and difficult question. How can I make some impact? And the resolution that I found for myself was, it's not just about reducing my own footprint, if you
yes.
will. If
Yeah.
I would want to do this, I could become a hermit somewhere in the woods and yeah, just live out there. But that would be great, right? Carbon footprint almost zero, but on the other hand, also no visibility at all. So you
Yeah.
couldn't be perceived as a good example for some traits and
Yes.
habits. So I ended up with, hey, you have to try be impactful with what you are good at. And yeah, happens to be that I'm an engineer and I'm a design review expert, so
Yes.
I try to impact things from that direction, which brought us together, I believe.
Yeah, I also think that you actually, and every one of us, we have a better impact if we can apply our experience, expertise, no matter whether you're a lawyer, engineer, or you're a driver, we can create bigger impact on the society by applying our knowledge rather than just live in the forest, you know?
Yeah.
So, sorry, your reduction of your footprint will be really, really small.
Yeah, I mean, we are part of a community,
We
right?
are,
So we
yes.
should act as one, I think.
Yes.
Yeah, indeed.
So, as an engineer, talking how you can impact the society. So I know that you have this method, but I want everyone to learn today about it, what it is, your design review method, and at the end of the interview, we actually learn how it can impact the energy efficiency, sustainability, and everything that is around green planet and green initiatives.
Yeah, sure. Perhaps to start with, it is of course not my method, right?
Yes, but you are one of the ambassadors of it, so let's say it that way.
Maybe, yeah. So, I mean, it goes back to design review based on failure mode, or DRBFM in short, even though it's a pretty long abbreviation. I try to avoid abbreviations anyway.
Yeah.
I rather keep it with design review, which leaves you a bit more open what it is in the end, because that may vary a lot depending on what context you apply it on. So basically, it's more about the mindset and culture behind
Okay.
the way how to communicate, perhaps complex technical content to others, to other domains, being understood. Because you need to know the main goal of a design review is that collaboration, right? You want that external, that other domains expertise to help you out discovering those critical, unsecure assumptions that may even not be aware to yourself. And for that reason, you need to bring them into your story, right? You have to make them, at least for a short period of time, an expert of what you are doing.
Yeah.
And this is kind of the challenge. But this eventually leads to good discussions and then sustainable decisions that you don't iterate all the time.
So maybe you actually can help us to bring everyone in compressed air industry together with this method at one table and to solve the problem of the energy consumption over consumerism of compressed air when it's not needed.
That would be a very bold goal, but maybe I can...
We can set it up as a very bold goal for the future. But let's talk a bit more smaller. Let's zoom in into the method. So what are the key elements? So I understand there is like the part of the collaboration, there is a part like of the technology, people brainstorm. What are the key elements of this method?
Sure. I mean, we are still engineers, so let's start in the technical context. So in the end, some main elements of the framework is thinking about functions before you jump into a design solution.
Okay.
So what's the upper purpose and goal of your design? And you can zoom up or walk the system up quite often, right? We tend to say 5 times why.
Yes.
I would extend that to ask as often why as it is needed until you understand the high-level customer need.
Okay.
But eventually you end up comparing design, including critical assumptions, with functional requirements. And I mean, this is nothing new in the end, right? This is a very common theme across several QMM methods, like FMEA and others. You often and always compare functions and design.
Yes.
But yeah, you still need to be very aware, and thinking in functions doesn't necessarily come like natural to the engineers. They are rather in the design quite quickly. So that's one element, right?
Yes. No, I agree with you that design, like as an engineer, I also would think, like I need to design a pneumatic system, and I start actually with the components. I put the components already on my layout, and then I think already about the technical terms, about the forces, the switching times of the valves. So because I already work with this domain, and this is where I'll be. But I know that there is like an upper level, so where the system will be applied, right? So in those kind of things, we have still to go to this step and start with the correct functional applications, right?
Exactly. And I mean, we have to be aware also our customers tend to think in solutions already. They think they already know what they need.
Yeah.
But in fact, often they just know what they want and
exactly.
not what they need. And the same for us, right? So we need to help each other out really and truly understanding the bigger picture goal and then help each other.
Yeah, I think the customer is always right. It will not be like the correct approach here.
Yeah.
It's rather than customer, we need to come in the discussion with each other.
Exactly. And I experience customers to be or become very open to this kind of discussion if facilitated in a transparent and collaborative fashion. And this already brings us, let's say, to another key element. As I said, it's more about the attitude behind the mindset.
Yes. Yeah.
So really going in with a thinking and a mission of creating an inclusive discussion environment, especially building bridges across the domains, right? We need different domains these days, and focusing the discussion on assumptions. That's, I think, if to name a third element of those key elements, it would be focusing on assumptions.
Okay. So can it be applied everywhere? Like, because I feel this is like everything that I apply in my life in general. So I look at the goal and then see what is their assumptions, or it is like the engineering part, or how do you use it also in your life? So where it is applied?
I mean, this question doesn't come from nowhere. As I already mentioned, the idea sparked during the pandemic in a totally off technical topic, right? So yeah, true. The idea of a good design review can be applied everywhere in life, basically, right? And also the framework thinking in functions and design solutions. If you stretch it a little bit, or maybe not even that much, you can apply it on almost everything. And yeah, maybe let's elaborate on this.
Yeah, I would love to. I would love to. Yes.
Okay.
Unfortunately, I wanted to apply it when I was late here today in the studio before.
Yeah, you could have done a design review on your traveling model.
Exactly.
Right?
So I want to see how I can use it in my life. So let's elaborate on that.
Okay, so we can still start in the, let's say, business context, right?
Okay.
We at Amazon and specifically here in Laatzen have a lot of context around factory automation. So typical products that we do is, for example, like this. Yeah. You are very familiar with this type of thing,
we're quite aware of the,
So it's just a pneumatic cylinder, right? And of course we could just draw a scope or a line around the interfaces of that cylinder
Yes.
and just think in this. But very quickly you can ask, okay, no one buys a cylinder for the sake of having a cylinder, right? Even though it looks quite pretty.
Yeah, it looks quite pretty, maybe just for a table.
You
as
wanna...
an art object, yes, but not that.
Exactly. We are not selling art objects usually.
Exactly.
The customer wants to fulfill some upper goal, right? They have other things in mind, and we have to start asking those questions. And maybe that cylinder is intended to open a door, and then you can go next level. Okay, what kind of door? And maybe you end up knowing that it's an emergency exit of, let's say, a football stadium, something like this.
Yes,
right?
I just want to say for all our viewers, because probably not going to come from the compressed air world, because the topic is very broad and super interesting. Pneumatic cylinder, it's a very simple device that is basically going to just have a piston and the stroke. Yes, and then it can go back and forth. That's it. So we will have the actuation. Martin will show you later, but it's extremely like in the so it's basically like a very, very simple device that goes from A to B and can move some certain mass.
You see Elvira has a lot of background in education.
Yes, exactly.
As well. Right, so basically it's just creating a movement, but of course it's important to know what you want to move.
Exactly, and how you're going to move it.
And if you think it further, if it's an emergency exit, maybe there are higher goals around safety or things like that. And out of the sudden you start entirely other discussions.
Yes.
But yeah, we can elaborate on this a little bit later. The point that I wanted to make here is functions like opening a door are like goals, right?
Yeah.
You want to achieve a goal. And
exactly.
There's a great similarity to daily life, right?
Yeah.
Like goals in daily life, whatever solution you find to solve it is they define the actions you want to do. They give reason to what you do.
Exactly.
And this is where you can start applying it in daily life.
Okay.
And I remember when you first came up with the idea of this interview, it must have been around New Year.
That's true, yes.
Around that. And I just heard a commercial on the radio for a gym or a fitness studio, something like that. And I was thinking, okay, why not making or sketching a real life example around losing weight, right?
Yes.
This was what this
fitness studio advertising on the New Year. Everyone knows that you eat for 2 weeks so much, and then you say, New Year resolution, 1st of January, I start going to the gym.
Exactly. So what I did, as I know you like working with whiteboards with me,
yes,
I couldn't resist creating a whiteboard sketch prior to this interview. So let's just take this example of losing weight and look what kind of function might stand behind. So let's move on
losing
here.
what we ate during the holidays.
Yeah, let me just keep that a bit here. So, you just see. I didn't like losing weight as it already is kind of a solution to something bigger. Yeah. So I wanted to phrase the function a bit more positive, and if you, for example, increase your fitness, then there is a more proactive goal.
Better emotional context
behind.
Also,
and you know why. Perhaps I don't want to be as exhausted when being up at my flat or whatever, right?
Exactly.
So this might be the goal that you want to reach. You can put some requirements to this, like, okay, now I start measuring when I'm satisfied with the output of that function.
Okay.
And this is where we could end up with the losing weight thing, right?
Exactly.
Let's say 5 kilograms after 1 year, right? Okay. Just as an example. So what would I start? I would come up with some sort of approach how I want to achieve that, right? For example, I wake up 2 hours earlier than usual so that I can go to the gym before starting all the whatever family logistics and going to work and that, right? This could be a valid approach.
Could be valid. Maybe not for me, but yes. Let's say for someone who can do this. Yes.
Exactly. So what we see on the right-hand side, that would be the function, our goal that we want to reach. And on the left-hand side, this is basically our design solution, our approach how to get there.
Yes,
right? How to make it a reality.
Yeah.
And as I mentioned, assumptions being important, this already goes with an assumption. If you think more about it, the most obvious one is that waking up 2 hours earlier and going to the gym contributes more to my fitness than sleeping 2 hours longer, right? But on this level, this assumption is pretty hard to challenge or to review.
It is, yes.
So a typical way also of the method is to ask for a model. And a very common approach is to compare it with a robust reference. We always, especially in product design, have something to build on. We rarely start building entirely from scratch, right? And this is what a review partner, often my wife, for example, for such non-technical topics, can challenge me, right? So, hey, Martin, tell me your model, right? Let me know why this is a good idea. And maybe I have this colleague at work who is doing this already, and he was successful after 9 months. Yeah. Again, just an example.
That's a good example.
But this could be my reference design, right? So this turns my assumption into something different, which is that I behave or am comparable to that colleague under all boundary conditions that may impact this this model.
Yeah.
So once again, we can put a potential behavior to this that we can compare with a functional requirement. So my assumption is that the black line will be true for myself like it is for the purple, I think, colleague.
Yes.
And this is what we then can start questioning. Is this assumption correct? And then you come into that kind of discussion fostered by a good visual here. And easily questions come up like, what makes us comparable? Do we have similar biorhythm? Do we have similar stress levels, nutrition, whatever you name it?
Exactly, diet also, right?
Or even logistics and all these kind of things. And you don't even have to go into all those, which could be pretty scientific subjects, right? Biorhythm of a human. But you can keep it quite baseline. Maybe the idea dies already to very simple reasons, like that colleague lives next door to the gym, right? And has no kids, so he can directly go there, exercise, and get to work. Where I perhaps just end up having 10 minutes at the gym until I got there and could get away from home and all this kind of things. So on a very easy level, this could result to, hey, there's no chance that this approach works for me.
Okay.
Let me help you find something different, or maybe even
or maybe you find another colleague, or maybe you find another approach, or go read a book, right, and find some solutions on the internet. Yeah.
Yeah, it could be anything. The point is that having a function visible and also making your approach more visible enables discussion, and it is applicable. And then you need to always connect how your design leads to the behavior. And this usually goes via a model. And that's kind of this, I call this design triangle. That's kind of my term for it. But essentially it just says you need to draw this connection, because in the model, that's the place where you can make your assumptions visible. And it could be, we often reject models quite quickly, but it could be as easy as, hey, let's just draw a logistics model here, just distances to the gym, how long does it take, don't go into all those other things I mentioned, and that's our model to just assess this scenario. And you ended up having a design review on a daily life subject.
Wow, that's amazing. I think I'm gonna apply it definitely to myself, to every single task that I have. You know, I have here a question. I feel, and maybe also our audience also will ask this question, how to start, because it looks a little bit complex. Yes, this example looks simple, but if we elaborate more, I'm going to challenge you right now, okay? So, for example, if we have function, increase fitness and lose 5 kilograms, and we go directly into this design. So maybe we don't go only to gym, but we, for example, we just walk to work. And then we change our diet, so we'll be able to lose and like feel healthier. So we should review those kind of possible ways, possible solutions. So where people usually can start with that? how like when I defining function, I understand that, but when we're already going into the design, what are the like, aspects? What are the main topics that they always should consider? Are there some other conditions?
Yeah. So you mean how can people get started?
Exactly.
Basically. Yeah. I mean, of course, I could go like, hey, people should internalize those concepts, right?
Yeah.
Of thinking in functions.
Yes.
Describing and visualizing, simplifying your
Yeah.
thoughts with that design
Yeah.
triangle
Yeah.
approach. And that's fair, of course, but
Yes.
it's already quite deep in the methodology, I
Yeah.
guess. So what I tend to recommend to people is more from a attitude perspective. First thing is you need to kind of become your own facilitator. And
That's a good point, yeah.
and what I mean by that is the method is for the engineers, basically.
Yes.
But as an engineer, you often find yourself in moderated sessions like risk assessments,
Yeah.
moderated by other parties like the quality department or someone
yes.
else. But this is really starting on your desk, and you need to take this ownership. Kind of, you can even start visualizing it for yourself. It can already create the first aha moment of, okay, I haven't been aware of this. Challenge your own storyline a little bit more.
Yeah.
Become your own facilitator instead
Yes.
of relying on others and perceive your role as just contributing the technical details or something like this.
Because I think it will then help you also to come into the discussion with other people, because what very often we see is you will have energy manager, mechanical engineer, quality manager, then there is a product manager, marketing, and then there is a client, and everyone is trying to bring a certain message to the client and help. But unfortunately, we cannot understand each other very often. As you said, right? There is a meeting and there is only on quality, meeting only on the system, sustainability. But it's everything that comes together. However, it still feels a little bit complex. I mean, do people really can use it just boards, or they should start already directly with some hardcore tools and simulations?
No.
Yes.
I think... So my favorite tool is a whiteboard, right? That's for sure. But besides that, I don't think. Of course, there are templates and things like that. You will find DRBFM templates. You will find all sorts of templates, also dealing with functions and designs, cross-domain mapping, metrics, all these kind of things. They are out there. But when you just try to start with becoming a good storyteller. And just anticipating a little bit those concepts of visualize how things are connected, bring those domains together on your board or in the way you structure or organize your material also helps, right?
Yes.
Maybe we can come to this a bit later when we also transfer it to the more technical context.
Yes, definitely.
But this also plays in there. We need to, when you start thinking in functions instead of designs or domains, you end up bringing the pieces together in one place instead of having one folder or one person responsible for the testing and one to take care of the requirements and another one to do simulation. In the end, you need those dots connected, and you can start doing so by thinking this way, right?
Yeah, I think it's right now I feel that it's even more important for people in the companies or in general. Again, I think back about the compressed air industry, right? We actually can map something like that. Maybe we can do it like next time and say, okay, we want to reduce energy consumption, but we still every stakeholder benefit here, every person benefit here, right? What we can do, what are the assumptions, and what are the models also for different stakeholders there.
Yeah, true.
So I feel like that it can be applied, and we're going to talk about it to the business models. It can be to the communications. I would like to go to our little cylinder that we have on the table, and talk about what actually we can do. I mean, it looks such a simple thing.
Let's transfer it to a technical
example. Yes.
And in order to bridge there, you asked for how can people start, right?
Exactly.
We already mentioned the facilitator aspect. I would add one other point to this, which is, it sounds simple, but often people don't dare to ask questions. They hesitate bringing up their concerns.
Yes,
So
it is,
really
yes.
asking questions is critical to
It's
this.
a lot of fear, because it's when you apply new methods, you always have like this resistance. I mean, we all have, right?
Yeah.
And we always feel shy. My question is going to be like stupid. So
Yeah.
so the question is like how to overcome fear. But I feel like actually with the whiteboard and with those like nice images and just like handwrites, it feels like more creative, collaborative approach where like you can loosen a little bit your.
Yeah, absolutely. And I think, I mean, one aspect is you need that, let's say, psychological safety with
Exactly.
your design review team. So there's a lot of creating that environment
Yeah.
aspect there. But the other thing is also sort of the attitude of all participants. I mean, as I said, it's for the engineers, but you can take the term broader, right? All parties, your logistics expert, whatever,
Exactly.
you have all those domains. They play an active role. They are not just sitting there in case they get asked, but they all can internalize a bit these
The
concepts
concept, yes.
and phrase their question also helping you out, not just saying, I don't understand this, but
Yes.
rather elaborate what they have understood so far, point out what assumptions they see or have identified so far, and hand over the discussion from there, so everyone can utilize the framework in order to elevate
Exactly.
the discussion we are having.
Exactly. No, it's important for all teams,
Yeah, and I brought one other example here.
Okay, perfect.
The picture may look familiar.
Yes.
I said that it came up during the pandemic.
Yeah.
On another topic. And when you remember the picture from before, we had design behavior compared with a functional requirement,
Yes.
right? And if you remember this hashtag flatten the curve thing, that's exactly this type of behavior, right?
Yeah.
You have visualized design behavior for a quite complex system in that case, right? A society compared with a functional requirement. And this is coming from somewhere, right? There is a breakdown. And the system here is nothing less than society with all those input parameters, if you will, right?
Yes.
There are laws, regulations, people, infrastructure, all this. There are boundary conditions like, I don't know, demographics,
Exactly.
religions even, climate, weather, or stuff like
Yeah.
a virus.
Yes, exactly.
Things that you can't change as easily, right?
Yes.
These, in
Yes.
technical context, we consider boundary conditions.
That's
And
true.
you could frame a very broad function here, like living together, right?
Yeah.
It almost becomes a philosophy session there, but still the principles apply. And likewise, you have some measure, some required output when you consider this being successful.
Yeah.
And in that case, I thought, okay, a healthy society,
Exactly.
mentally and physically,
Yeah.
might be a good outcome. And there are even criteria that you can measure this with, like
Yes.
mortality rate and things like that.
Yes, that's true.
And this is where I just wanted to point out the bottom line here is if we try to find that journalist in us that can simplify and condense a subject as complex as virus spread during a pandemic to a very easy visual
Yeah.
that in the end is nothing less than design behavior compared with a requirement.
That's true.
That is kind of the approach, right?
Yeah.
And those people these days, often YouTubers or bloggers,
Yes.
whatever, and don't get me wrong, media play a critical role during a crisis, right?
It does.
I don't
It
want to
does.
elaborate on this here, but
Yes.
the message is try to find that journalist and condense your story. And this helps then also for the technical
Yeah, because
context.
this is actually the tool. It's not only to create, to have an outcome, right? And like to achieve the goal, but it's also greater communication tool.
Yeah.
Also outside your framework. So this also could be used, right? So when we go back, for example, to the journalism, it is a perfect example as just a person that doesn't understand anything about the viruses. I mean,
Yeah.
not so much. I can understand now the framework of that. So as being an engineer, I feel like that I also can use this tool to communicate not only with my team or with my client, but in general, to show, for example, on the political level, why energy efficiency is extremely important for compressed air system and for pneumatics. So, and this kind of it's kind of like the language that...
Yeah, and it's a common language, right? That's exactly the charming part of visuals. It is a universal language, and it almost comes down to also engineers, technical people like we need to become good storytellers in order to be impactful, right?
Exactly.
Which is where we started this conversation.
Exactly.
And perhaps just one point to make on the visualization. Yeah. I like drawing, right? Yes. You see it. So in my case, often drawing a picture is equivalent to a good visualization. Yeah. But often people hesitate then, okay, Martin, but I'm not that good as drawing. And you can question if that is really good drawing. But anyway, it doesn't have to be a drawing. So visualization also means creating a picture in someone else's head, right? A good metaphor can serve the same purpose. I often brought up the example of in pneumatics we are exhausting machines, right? Yes. If I want to explain this to my child, I rather perhaps put an example like deflating an air mattress, right? The first piece of air gets out super quickly, and then the rest you need to squeeze hard, so it goes like a curve like this, depending on the pressure. And you don't need a drawing in order to create that picture in your mind of your last camping trip where you exhaust this air mattress. So this is what I mean with creating a good visualization.
That's true. Yeah, as well as also for compressed air, right? Like when you explain someone who never saw it and never had the experience with that, but it's still the most expensive utility in the facility, right? You have electricity, you have water, and the compressed air is as well as utility. So, and you need to think about that way, how I can reduce the consumption. When I look, for example, in my house, I switch off the light first, right? So I switch off something that I actually don't need when I'm not there. The same parallel to the production line machine. In the lunchtime, the machine should be switched off. So we need to have the shut-off valve for that. Or, for example, then I start to design and make on the system level. If I go in my kitchen, see all the components, all the supplies there, a toaster, the hot pot. So I maybe get a more efficient one, the dishwasher also more efficient one. And then I already think about the generation. So all the energy efficiency is basically the demand-driven topic. First, I switch off the light, and then I already think to change the provider of my electricity. Yeah. So, and I think for a compressed air, for pneumatics, is the same thing. The point of use is extremely important. And sorry, I'm already going into the point of use.
That's absolutely fair.
And one of the point of use, one of the light that you have to switch off when you leave your house is basically cylinders, because they use compressed air to move, to perform the mechanical task. And design review also can actually help us to design application of those cylinders.
Yeah, sure. I mean, we build it up to this point with those more daily life examples as we started from the collaboration piece and the universal nature of it being rather a storytelling approach coming from a technical background. But sure, it can apply to the technical world as well. And I even like your thought process of starting at the demand level, because that basically is equivalent to this function that I started with, right? You need to know why you need this in the first place.
Exactly.
We are not buying something for the sake of having a cylinder, right? Despite the art object
So we need to move from A to B. Maybe I need even an electric drive here, or maybe I need here a pneumatic drive. So I need first to start also with this, and then once I choose it, then I already can design the system already around that.
Yeah, and this brings us to more complex situations, right? I mean, you are in the situation of visiting customer sites, right? Yes. I know you have seen a lot, and it is not just one device that is energized somehow. It is multiple of those.
Exactly, it's the full system. Yes.
Yeah.
Multiple devices. And first the question is like, do I actually need here this function, right? The second, what I need to perform like this function, and then already can design the system in order to bring the air until that point of use.
Elvira, let me ask you a question
Yes,
at this point. I already elaborated a little bit on that design triangle aspect, and I mentioned that the model is the ultimate connection element that brings you from what your solution is to how it behaves.
Yes.
So I know you have a lot of background in analytical approaches.
Yes.
So what is your experience around engineers applying what they learned at universities later on in their business context?
Well, I have an experience teaching engineers, both in teaching students first at university, right? Both in Germany and in Italy. And I would say the main engineers can find the solution quite quick, in the sense that, but they start already from the design side, right? So for example, if I'm a mechanical engineer, I focus only, and I need to design a cylinder. Usually they would go directly into the 3D, into the SolidWorks, design a cylinder mechanically. But then you need to have a fluid power engineer who would actually to connect it to the system and will learn how to calculate the forces, the consumptions of it, the switching time, and so on. And although they are usually can be one person, but in general they go directly into the technical side. So, and this is what I think it's a little bit missing, this holistic approach, you know. So it's very domain focused. So inside the domain it's great, but once you need to connect A with B with C, and then you need to see the full holistic level, like just to zoom it a little bit out, this is a little bit difficult. So I think this is one of the main things. Another thing that one of the challenges is, and I'm working quite active on that, at university we learn, and I did the research, right, in compressed air. So, and I did the PhD on that, and then you research so many things, you're so excited about the matters, you use like cool simulation tools, you have like the test lab and so on. And then you come into the industrial world and it's not like that. You go into the factory and you have great maintenance team, great like engineers there. But one is responsible for this piece of the machine, another one responsible for that piece of the machine. One is responsible for the production line, and he talks with Emerson, for example, on the component side and so on. And one is responsible for compressor room, and they don't talk, but I mean like they don't even like think that they have to talking with each other and communicating with each other. So I think this part is a little bit like missing in engineering. So it's very one domain, like one a bit one-sided story.
Yeah, I guess so. And I experience the same quite often, to various extent. I mean, obviously we are aware of that we have mechatronical systems, and there's a lot of more software and intelligence coming in. So this collaboration is always there, but still we have different domains background, and there is quite often a certain fear of the complexity, let's say.
It is, yes. It is a fear of the complexity, yes, because you don't feel as an expert everyone has a fear. I have a fear of a complexity. I feel that I'm an expert in one field, but like whenever I go into the next one and I'm trying to connect, I need to learn a lot, and I feel stupid very often, and no one likes to feel stupid, right? So we cannot blame engineers for that. So, but this is very common.
Yeah, that's for sure. Let me have a drink.
Sure. Yes, but I feel like that we actually can bring everyone together in one table by solving this complexity.
Yeah, great. Yeah, solving this complexity. I think that's really an important point here. And I think what I experienced being a very good approach to this, to kind of overcome this complexity issue, is not putting the measure to yourself, having to know all the details in a quantified way.
Exactly.
But instead really zoom out into the larger picture system and then stay qualitative in that fashion.
Yeah.
And then once because this can be very quick, it can be fast and easy, you can point out those assumptions in a brainstorming session without having to provide any numbers, right? You can think of various boundary conditions, even from a plane crash into your facility, right?
Yes, I
Which
hope not, but
hopefully it won't happen, but in a brainstorming you can even go to the extremes very easily to then assess, okay, let's step back and see what is even realistic in our case.
Exactly.
And then you can put your scope, narrow your scope to those areas that you don't feel comfortable with, you don't feel like having the knowledge for, whereas you can check others as being, hey, this is common stuff to us.
Exactly, yes.
And then you can start zooming into those uncertain but impactful areas.
Yeah.
And this is where you can start collecting the numbers. Then this is where you can start building your models. And I think this is an iterative process, right?
Yes.
You close some knowledge gaps and then you zoom back again and see, do you have enough decision material already to make the next step? Or if you don't, and then you zoom in again.
Yeah, zooming out, I think it's so important. So because you can identify the areas where you're working, so that the boundary conditions, the risks, the qualities, the common goals, the functionality goals, the sustainability goals. And you actually can bring also all the experts from that, right? You can bring the quality manager, sustainability manager, energy managers, someone from your client side, on the table, and to ask them what they want from their perspective. And once everyone just express their wishes, you can start putting this as the main functionality of your system. Is it correct? And then you can go already zoom in and talk to them and collect all the
It is
numbers,
way easier to onboard those other domains in the rather qualitative discussion where you don't need all the details for everything. You can brainstorm way more efficient and faster and creative. And then, of course, you can assign some homeworks, let's say, for the detailed parts. And then, of course, you need some modeling. But even there, even if you go into a focus area that you want to start building a model for, that you can go into, well, how accurate does this model have to be?
Yes.
And there also one recommendation that I found is we can start with really simple baseline models, right? Like we learned at university. Of course, an actual movement is more complicated and not always a uniform acceleration with constant forces and all that, just to make an example. But you can start with easy models like this because it allows you to sense the impact and direction of your design parameters.
Okay.
And I elaborated on you often compare with a robust reference design.
Yes.
And often for an old legacy product, whatever that reference design might be, we often are lacking cause-effect knowledge, how it exactly behaved inside of it. We know it performed well under these circumstances. So this type of qualitative modeling without numbers but still some equations helps us sensing, okay, changing this parameter in this direction, does it affect the outcome of the function in a positive or negative way? Are we changing towards the safe side or towards less reserve? And if you just check that everything is changed towards a more robust side, you basically still don't need the numbers, right? You can still stay qualitative and put your effort into where you have those insecurities. And only there where you change something into a direction where you reduce a reserve or come closer to a limit, then of course you need to start becoming more detailed. You need to calculate a bit more. You need to back up this with testing, probably to close other assumptions.
Also some gaps, that's true.
Exactly.
Wow.
Yeah.
Sounds like a very good approach. I'm really curious how we can apply into the technical.
Yeah, I had you wait quite a bit now for the
No, but it was
technical
extremely
example.
important, yes. So let's come back to our cylinder.
Sure. Yeah, let's get back to that cylinder. I promised one last more technical example.
Yes.
To also draw the link. So let's just stay with this door opening cylinder that I started with at the beginning of this interview, right?
Yeah, it's very common application actually for pneumatic cylinders.
Yeah, and I mean, you could likewise talk about an electric linear actuator, which we do as well, but pneumatics is, let's say, our favorite background, so let's keep it simple here. And I just put some potential specification items here that a typical customer request could come with, right? They might ask for, hey, we have this cylinder, it's opening a door, it has some stroke. They may put some further information like it moves a 200 kilogram door.
Yes.
We have supply pressures 7 to 8 bars, whatever. They provide the stroke of the cylinder that they want, perhaps some dynamic requirements or leakages. And I put those elements quite loose here, as this is how often a specification can appear.
It is a very typical specification, I can assure it, yes.
Okay, thanks for that confirmation. Yes. And then, of course, we would try drafting a bit more visible functional requirement out of this. Okay, so, well, we are talking a door opening cylinder, so our function is opening a door here. It's my favorite training example.
Yes.
And we could also visualize this requirement a bit better, like, hey, after maximum 33 seconds, it needs to be retracted fully. Okay. And fully means, in technical context, always with a tolerance, of course, so there's no perfect stroke. So this could be, let's say, a function, and then, of course, engineering could go ahead and assign a design to it, right? So they would size this cylinder, foremost the diameter of it in order to move that door. And they will also do some model in the background, right? So there is some dynamics model for the cylinder, for example, accelerating this mass of the door with your pressure force and all that. And it ends up with a behavior like this door being retracted within those 3 seconds, right? Which you then, and this is the backbone of the method, can compare with the functional requirement. Yeah. So this is nothing new. We do this kind of automatically, but often we don't visualize it that well.
We usually have some equations or calculations.
Yeah, the requirement stands somewhere there, but we often rarely overlap this that you can really point with your finger on the problem. But this is exactly what we want to do in a design review. We now want to challenge this assumed, let's say, feasibility confirmation, if it's true. So we put an assumption, and a pretty obvious but often hidden one for a request like this is, I would automatically assume that the movement of the door is equal to the movement of my cylinder. So I have a linear movement. Because if I just put 200 kilograms and a stroke of 1 meter and the dynamic of this, I automatically draw a line around the interfaces of my cylinder and take this for granted.
That's true.
But unaware, I basically envision a door that looks like this, that is kind of retracted simply with the cylinder. Yes. You get my point?
Yes, of course.
And we might be right with this. This could be a train door, right, where the passengers enter the train, for example. Yes. But we also might be wrong. And visualizing this helps you zooming out and going back to the customer, and you have to start sketching that door. And if you don't know how it looks like, you need to ask your customer. And maybe the real life door rather looks like this. It is perhaps a rotating door, right? Yeah. That may be much longer and come with its own additional geometry and parameters. Exactly, yes. That would fundamentally change your physics, right? You have to move a different inertia, whatever. You have a different system now. Which also might not be as aware to the customer, right? They might think, okay, we gave you all we knew, right? 200 kilogram door, stroke. Exactly, we already pre-sized, let's say, the stroke we need, and that's it. And this is where the concerns arise. And you can make them visible, of course, right? If you add those additional physics, and I didn't sketch the equations and stuff here, we are more on the high-level discussion about it. But you get your concern right there. The door might be too slow.
Too slow, exactly. So what we would do in this case? How we proceed further?
That's exactly the point, right?
Yes.
You have this visualization, and there's that connection with this design triangle, so that you can discuss your options, your design parameters. And as I kept this on the main function level here, we didn't zoom into internal functions of parts and components, sealing between parts and transmitting forces and stuff like that. So there's deeper layers of cause effects that you can assign the same approach to. But on this high level, you, for example, could simply adjust the diameter a bit higher, right, so that you have enough force left to open it as dynamically as you wish. But the connection is there that allows you discovering those assumptions, especially when you go deeper into inner cause effects. It's very helpful. And then the effect of this, you can see which functions are affected and how it is visualized. So this is basically, and let me point out the similarity to the examples before, right? I tried to keep the same visuals here a little bit with the function on the right. It always comes down to the same. You compare requirement with the behavior, and you allow everyone to contribute to the discussion by bringing those things together on one page and visualizing it.
Yes, that's true. Because then you actually can start thinking about also your pressure levels here, right? So you can also get the same diameter of cylinder, but maybe your pressure is higher there. Or then assumptions, if it is between 7 and 8 bar, it's quite a big gap, still 1 bar. So then you already go more into the already pneumatic system level, right? So you go already...
Absolutely. And like I said, I put a very simplified visual here. In fact, if you look at this force, it of course is not just a function of the diameter, but also of the pressure levels. And you have resistance forces in the system from all the ceilings. So usually there are way more dependencies than just a diameter. And each and every one of those is subject to being a potential parameter to affect. Some are in your hands, in your design authority, if you will, whereas others might be in the authority and limits of the customer, which can be also a given, a suitable way to solve the problem, if they can be onboarded on this discussion likewise, like adjusting a pressure level or things like that. And this allows you that type of discussion.
Okay, what would be the next also step in this kind of case, to consider boundary condition where the cylinder, the door is, right? Is it indoor, outside, inside? What about the temperature? Maybe it's on the North Pole and we have minus 50 degrees.
Absolutely, You remember in the other example where I had those other arrows to that black box visualizing that there are always boundary conditions?
Exactly.
These are the parameters that you can't change that easily, like your environmental temperature and all this kind of things. And this is exactly what is also supported by zooming out, right? You need to know what's happening, where it's happening, and all that. And not just by believing in numbers of a specification, right? Like there are temperature ranges, of course. Customers will give you these type of things as well. But often it's just a list of requirements. And it doesn't come with telling you what use conditions, what stages there are. There might be maintenance steps where it becomes warm because they heat clean it, whatever, but it won't actuate at the same time. So we can avoid over-engineering if we look at those different stages by zooming out. And we can suggest more systematic or more system-level approaches in our solution offering.
Okay.
And I mean, this is, I think, perhaps the biggest potential also looking from a business perspective. We can, of course, talk the single door and the one actuator, but this is not where the energy is wasted.
Yes,
right?
Of course. Yes, we also need to, even on the functionality level, the time of the cylinder movement will depend on the throttles, on the check valves, on how you control the velocity of cylinder, right? So of the valves, switching times of the valves, the tubing, the length of tube, and then at the end it will come also to the consumptions and the entire system requirement for the entire compressed air system. So going to the compressor. So how would you, from this component, from this more mechanical requirement, how you then go into the systematic level in the system?
Yeah, I mean, I started this example in my very easy starting words with, hey, maybe we are talking an emergency exit of a football stadium, right?
Yeah.
I don't know if there's any football stadium out there using pneumatic cylinders for their safety doors, but you bear with me with this example,
yes.
right? But if you look at this, that this is an emergency exit, basically, right? If we come to this level of discussion and not just taking for granted, okay, we have a door, we know it rotates, but we already enter a discussion of, hey, there are safety considerations of that owner of that football stadium. So this elevates our discussion, hey, maybe we can offer you additional functionality as well.
Ah, okay.
And also rethink the appropriate design. Maybe it is a more safe layout having a spring return in the case of a pressure leak or whatever.
Yes, exactly.
Right? If you have a fire in your football stadium, maybe your pipes get damaged and you need perhaps a fail-safe spring return on your actuator.
Exactly, yes.
And you can think this further. If we are talking a safety product here, maybe we also want to detect the safe position, right? So you can bring in additional features. And then, like mentioned, you won't have just one emergency exit. You probably have several of them. So you enter having pneumatic
control
valve.
System, right?
You have a valve system and all that.
Yeah.
You are connecting several doors. Maybe you are interested in the air consumption of that whole system.
Yeah, of course.
Maybe you want to bring the status of all those positions together in some sort of dashboard.
Yeah.
So, and this is all functionality and products and approaches that we can offer.
Yes.
So we would kind of don't take the chances and the business opportunities that we have if we would just take for granted the initial specification and sell a cylinder that hopefully does the right job. So these conversations are not just crucial for good design review internally, but they also can elevate the discussion with the customers.
Yeah, that's true. So because you basically provide the solution to the customer. Very often customers, they are aware there is a cylinder, there is like some other components, they use compressed air, but they're not engineers who actually design those systems, right? So they have the solution provider maybe, or maybe they just design it themselves and they don't know how to solve it. So here in this case, it is the full solution that actually covers few topics, right? So we have the functionality, we also have the safety aspects if it is relevant. We have also some boundary conditions in terms of what is the pressure, would be like the temperatures and so on. And also the other thing extremely important is the energy consumption of entire system. Yes, maybe in terms of the cylinder that has this exit, it's probably not gonna work not gonna consume as much as you can imagine, but we have pneumatic cylinders, they consume a lot of energy. So in general, a lot of compressed air. So it would really be extremely important to see the health of your entire system, the performance of your entire system, right? And not only on the energy consumption, sustainability side, but you can see if something is leaking, if there is like any pressure drops there, and if the system actually gonna still like function when you actually need it. So it actually covers all those topics together, and with that you can bring the entire team. Yeah,
and it's really about this attitude, right? Hey, let's be curious. Let's challenge also the customer. Hey, let's zoom out a little bit. Let's go to your side of where the problem is happening.
Yes.
Let's do it. Let's understand what's going on, and oftentimes also the customer learns more about their system, right? We just need to be open to this kind of
I really like this approach. The other thing that I wanted also to tell that engineers, we are very creative people.
Sure.
In general. So it's not just like we're thinking in one black box, but in general, we are very creative people and trying to find the solution. And this kind of the approach can really help, like just starting from scratch, starting from the whiteboard, when you still don't know what actually going to be the solution, you can put all the aspects together. Martin, how we can help the environment with this? How it can be used for what we started with the CO2 emission 1.5%. The passenger flights are 2.5%, and compressed air is 1.5% emissions. Imagine
are numbers.
Yes,
yeah,
the impact that could be done only with the correct design. Well, we already have an efficient system. We already have components. We just need to think through.
Sure, and I mean, this might be just a humble addition,
yes.
or a humble support to all this, as I also don't have a technical solution or anything. But on the other hand, having a more meaningful discussion around your topics serves multiple purposes, I think, in this sustainability scenario. One is your engineering work becomes more efficient, right? You spare a lot of iterations just due to misunderstandings, not getting requirements right, not identifying critical assumptions in your design, causing you to iterate. Also pretty attractive from a commercial perspective as well, right? You can increase or improve your time to market and save costs that come with having additional samples and all those iterations.
Save also some testing time, right?
That's the other point that I wanted to mention. We elaborated on how critical a model-based approach is to this, which doesn't have to be super sophisticated, like I pointed out, right? Easy analytical models can serve the purpose. But having those is critical to not trying to solve any issue by testing. I mean, pneumatic air is the most expensive type of energy you can probably think of. So doing a test where you are not super certain that it solves your knowledge gap can be a huge waste. And approaching more model-based helps us getting those tests down and just put a target-oriented test in place where we know from our analytical pre-considerations what the critical test conditions have to be, what my extremes are, that I can really focus on measuring the right things under the right critical conditions that allow me integrating the result into my analytical or simulation model, and with that don't waste energy on unneeded testing, and also have a more sustainable engineering model that you then can later on, when your product is out in the field and you need to retrofit it or make changes because of a new use case, whatever, you don't have to reinvent that wheel, but simply adjust your model, do this little additional test to consider the new aspect. So this, of course, all saves energy if you go more model-oriented.
I also think, I always say that, that the most efficient system is the well-designed system.
And I mean...
That's true. So that's the thing. I just confirm my words. But in general, like the best functionality usually performs the system that has the lowest energy consumption. So it's this is kind of like the rule, and like before we start the monitor, before we need to go into the fault assessment or anything else, it's extremely important to size and choose and design a system correct. And in this case, you will already get the correct baseline for your energy consumption, and then you can start monitor in terms of the system performance.
And maybe you mentioned the correctly sized or dimension system is a baseline. And as a perhaps third point to how this type of method helps you, it's basically an inherent part of the function assessment that when you look at the functional requirements, which is basically the output, right? What we have here on the right-hand side of this black box. There are usually three criteria to this. One is the dimension of it. In this case, how much stroke, how far does the door need to be opened? Then second is the dynamics. How fast do we require this? And the third is always something around efficiency, like a maximum leakage and an air consumption. And with that, you basically can never forget talking about energy efficiency.
Yes.
Besides having it a way more present requirement in specifications these days. So this is another layer where it can help going a more function-driven
That's true.
approach.
It's always good to start, and I really love the fact that you bring everyone to talk about. So bringing everyone and talking now about you. You're an innovation champion, right? What are your next goals in the innovation topics? What is driving you now?
Yeah, I mean, innovation is an interesting term. We apply it to a lot of things. Basically, it's about making something different. And not just for the sake of doing something differently, it also needs to be successful and interesting in front of a customer.
That's true.
So we want to monetize it in some way. Exactly. And this brings us to not just thinking about the technical product layer, but also around the less technical needs of customers. And this is where I found that design review world that I come from, more founded in the technical discussions, be very much applicable to the more broader type of conversations as well. I mean, we had those examples earlier with the increased fitness thing, or even the live together pandemic example.
Thing,
These are not technical functions, right?
Yeah.
We also use the term jobs to be done in the innovation topic.
Yeah.
So basically things that our customers, that we want to achieve and make progress on. And these are not just technical, but also social needs, emotional needs.
Exactly.
And they might be as relevant to the decision making of working with one supplier or another, how well those needs are understood. And this is where the approach stays universal, right? I mean, increasing fitness is a rather technical phrasing, right? It's really about being able to make the heavy lift, whatever.
Yes.
But I guess the most common reason is rather something like being perceived as attractive, right?
That's true.
for most people. So rather an emotional or social, in this case, need. And we can try coming into this type of conversation also in the technical context. Not just asking our customer how the next generation of cylinders or valves can look like. They
would expect,
but be more open and try to understand what keeps them up at night. Right? What is stressing them? Also depending on their role, right? And then we quickly come into conversations that bring up way different topics, like they might be bothered about their safety reputation. There might be safety goals, right? A big hazard in a football stadium, I think, is not very good PR.
Exactly.
They might be sustainability driven, reach those goals, or they simply might want to reduce stress around even a test case emergency scenario, right? Or
of course.
Knowing where the fire guard needs to come. So understanding when we already start talking about services or dashboards and things like that, better knowing where the real underlying pain points are can help us providing them the actual solution to their problem, which might be visualizing data that is meaningful to them or meaningful to stakeholders of them that they need to present to.
Exactly. So more like action-based rather than just giving some information that they have to then understand and interpret it in a some
exactly.
way.
And this might have great value to them, right?
Yes, that's true, yes.
So this kind of brings us, this is also applicable to business model innovation and not just technical risk assessment, if you will.
Yes, so basically the next steps for you is more elaborating onto the new business models and how customer actually can get rid of the headache, I would guess.
Basically.
The main idea,
So it's a back and forth, and basically we just replace terminology a little bit, at least from my point of view. We don't always have, or the other way around, I applied a function terminology on non-functional examples even 5 years ago. but now just realized, hey, talking about jobs to be done is just another terminology. You might also call it user stories or whatever.
Yeah, that's true.
And finding those connection points also in terminology also helps training those things or make it easier for an organization applying and adopting to such ways of thinking. If they don't see their wheel reinvented, but they find the similarities to what they are used to in their daily life.
Yes. Yeah, Martin, thank you so much. It is extremely important and so interesting. I think that this first steps on the awareness, on the education, bringing in general this approach more into the different topics, not just like to the strictly engineering methods, because you said, yes, this exists, there are some tools, there are some guidelines, and I'm sure that some of our viewers, of course, know about it and we use it also in their daily life. But in general, how to zoom out the problem, how to bring the functionality, how to understand the boundaries, the design and the behaviors, it can really result in opening more doors. And I feel very positive and confident that it's gonna impact a lot the energy consumption of compressed air system. So I really think this is extremely important piece in this very complex puzzle of the sustainability.
Thanks. I mean, communication is a big puzzle piece, and it is not the typical persona aspect of the engineer to be the storyteller.
Yes.
But trying to improve on that axis is important.
It is.
And that's kind of my learning from this as well. And a mentor of mine used to say there are no wrong decisions, just wrong assumptions. And I really turned this phrase into like a living motto even. So de-risk critical assumptions first also allows you to not wasting and dumping your money into an idea that won't be meaningful in front of a customer in the first place. So,
That's amazing. Martin, thank you so much.
Elvira, thank you for visiting us here in Laatzen and then hosting this interview.
It was such a great discussion, so I'm sure it's going to be many questions. So, and I hope that we will see each other next time and elaborate more on the different topics.
Yeah, I'm looking forward to, and thanks for having me for your interview.
Thank you.
Have a good time.